See, real quick, back to this one. He said this is just the ln of x minus 3. And he's right? This is totally right. But I want to say something. Technically, you did a little u substitution. You let u equal x minus 3. What was du?
1 dx.
1 dx. Right. So technically, you did this. And then when you replace this, it turned into a 1 over u du. And there was no 1/3 or 1/5 or 2 or anything. So this was nice and cool. And maybe you didn't even realize you did u substitution. Maybe you didn't even realize you did u substitution. But on this one, you better not forget about it, because u substitution spits out a 1/5. Right. So you could almost say, dude, this is the natural log of 5x minus 4. I think that is what he said. And he's totally right, except for you got to kind of go through the steps of the u substitution to make sure you see that it spits out a 1/5. I mean, I know it does, so I just put a 1/5 out front. Do you want to see the steps? Do you understand the steps? For the 8th time today? Right. You let u equal the denominator, and du is a 5 dx. That's the thing that's spitting out the 1/5. Because when you replace all this, again, I'm starting to talk fast now. Maybe I should. I mean, I feel like we've been on u substitution for several days, but it worries me. Yeah. It's a topic that worries me, so you can tell maybe. When I replace all this, let me see what happens. 1 over u. The dx is what? Is the 1/5 du. Okay, so I put the du there and the 1/5 out there. That's me replacing the dx. And now it's ready to be called ln u with a 1/5 in front of it, isn't it? Right? Look at it. Now there's nothing to do now except call it ln u with a 1/5 in front of it, right? So what about this one? ln of this. What does it spit out? Negative 1/2. Good job. Cool. From that, yeah. Good. You want to see something really funny? So this is easy, and this is the answer. But I want to show you what somebody who has nothing better to do might do. Like somebody like the book. You can play around with these logs sometimes using log properties. Just watch this a second. You could, this is 10 minus 2x. If you sort of factored out a 2, it'd be 5 minus x, like that. And now I have a product. And so if I have a product, I can make it the ln of the 2 plus the negative 1/2 ln of the 5 minus x. Okay, hold on. What did I do? I took the log of a product and broke it into the sum of those two logs. That's a special log property. The log of a product can broke into the sum of the two logs. The 1/2 was in front of both of them. The negative 1/2 is in front of both of them. So now it's sitting here and it looks like this. Now check this out. Because it's an indefinite integral and it's got this arbitrary plus c on the end, you know what they'll do now? Yeah. They'll take this, which has no variables in it. There's no variables here, and it's a constant, and they'll dump it into this constant because it's an arbitrary constant anyway. And so then you'll look up your final answer and it'll be this. It'll be this natural log of 5 minus x plus c. And again, we had this a few minutes ago. But when I look it up in the back of the book, they might have this. It looks different. It looks like I'm wrong. But why am I wrong? I'm not wrong. I'm not wrong. They just did these couple fancy moves here using log properties. And when they can get a constant like this, why keep an if I've already got an arbitrary constant, let's just dump this in with the arbitrary constant. It's logical for them to do that. That makes sense.
Can we say just divide 10 by 2 and negative 2 by 2 and get 5x, 5 minus x?
Well, that's the result, but
Right.
but you don't want results without why. I mean,
Right.
right? You want to know why. So no, you can't just divide. But this is why though. Okay. I don't know if you're doing some homework, you may run into that. They may do some they do that a couple times in the homework. If you're doing some homework and trying to check your answers, you may see something weird with these logs, and that's because they made use of a log property somehow. Well, okay. There's a lot of good problems. In 5.7, I'll just keep going. You guys can ask me. I mean, you can do some of these anyway. But I also 99 was a decent little sort of word problem. 100 looks okay. 101, 102. I didn't assign all those. I assigned 99. But I don't know. If you're wanting more of a challenge, there's some up there. Let's do this. Let's move into this last section, 5.8. Now, and again, all it is I got to tell you a couple more new rules, and then Calculus 1 is sort of over. Listen, we learned about this derivative rule back in chapter 3. What did we learn? We learned how to do the derivative of arcsine of x. It was 1 over the square root of 1 minus x squared. I think when it came test day, I think I gave you that formula. I told you didn't have to memorize it. Is that true? So far, I've asked you to memorize everything in this class, most everything. But for some reason, I didn't. Anyway, you might want to memorize it now. Here's another one. The derivative of arctangent. It was 1 over 1 plus x squared without a square root. Here's another one. The derivative of arcsecant. What was it? 1 over x in front of the square root of x squared minus 1. I think. Hey, there's 3 other arc-trig functions. There's arc cosine, arc cotangent, and arc cosecant. I don't know if you remember, but I'll remind you now. Their derivative formulas were the exact same formulas with negative signs on them. Arc cosine was the negative of that. Arc cotangent was the negative of that. Arc cosecant was the negative of that. So in a way, there wasn't 6 of these derivative formulas. There was 3 of these derivative formulas. The other ones were just the negative of them. Is that okay? Well, anyway, now we're not doing derivative formulas, though. We're going backwards now. So if you walked into this and someone said integrate it, what's the integral?
Arcsine.
Arcsine. If you walked into this and somebody said integrate it,
Arctangent.
it's arctangent. If you walked into this and somebody said integrate it, it's arcsecant. So I've got 3 new antiderivative formulas to give you. Not 6, but 3 last new ones here. And what we do, though, instead of being specific, see, this was specifically an x, and it generated this 1 and this x squared. So with our antiderivative formulas in 5.8, we generalize it. Watch. So instead of this formula, what it is it's a 1 over, instead of a 1, it could be some other number, a squared. Could be a 9 or a 4 or 11 or a 16 or a 17, or it could be it doesn't have to be a 1. It could be an a squared, and the variable doesn't have to be x. It could be some kind of a u squared. du. So Jesus, what am I trying to say? This derivative formula was very specific for a x, arcsine of x. But when I do the integration formula, I broaden it, I generalize it to an a squared minus a u squared, and then the answer is arcsine u over a plus z. Let's do another one. For this one, it's this formula, except I generalize it. I make this an a squared plus a u squared du. And so when we do the antiderivative, we get arctangent, but it's not just arctangent of x, it's this. It's 1 over a, I think, arctangent of u over a. So what am I doing? I'm writing down formulas and telling you to memorize them. I really am treating you like a robot. This one's different. This is u squared minus a squared. Look what I'm doing. I'm generalizing this formula. Instead of a 1, it doesn't have to be a 1. It can be any number. Any number. And this doesn't have to be just an x. It could be any function of x. That's what u is. U is some function of x. But if it fits this pattern, du, then the answer is arcsecant. 1 over a arcsecant u over a. I think you put, hang on, u over a. I think we put absolute value on that u.
Yeah.
So 3 more formulas. Now, and I'm skipping 5, 9. So in a way, you've learned all your integration formulas now. All your basic integration formulas. Your book tells you that, and somewhere in the middle of 5.8 on page 360, I mean, you guys, I don't know what kind of books you have, but finally in the middle of 5.8, they give you this, that you got 20 integration formulas now that you know, and you can integrate anything you want. Well, wait a minute, not anything you want. Some stuff, if it doesn't fit the formula, you can't integrate it. I'm sorry, I misspoke. On page 360 is a little table of all your formulas. Integration table. And I guess you should know them all, unless I decide to give you some. I'll keep you posted. I mean, you should know them. I've been asking you to memorize all this stuff, but... Anyway, let's try a problem now. So, can you do this integral? I think so. I mean, look at him. Look at his form. Which one does he look like? Does he have a square root? Does he look like that, an arcsine? Does he look like an arctangent? Which one does he look like?
Arctangent.
Thank you, he looks like an arctangent. If he is looking like an arctangent, maybe you could identify the A for me. What would be the A?
4.
Okay, first of all, you gotta understand this. A is a number. A is never a variable. A is not x. So the u's are functions of x's. The u's are the variables that relate to x's, and the a's are the numbers that relate to numbers. So anyway, so who's the A?
4.
A is 4, but that's not exactly true.
No.
A squared is 4. A squared is 4, so what's A?
2.
A is a 2. What is the u then? If that's u squared, what's u? U is x. Hey, when u is x, you never do a u substitution. It's kind of ridiculous, because all you're doing is replacing the x's with u's. And by the way, what's du?
1.
Dx.
Yeah.
I mean,
Yeah.
I mean, if you ever think you're doing a u substitution and you're going to let u equal x, you kind of don't really do that, because all you're doing is changing all the x's into u's. Nothing. If u equals x, there's no 1/5 coming out. There's no 1/3 coming out. You're not really doing anything. But I am identifying. I'm sort of just identifying it for the. I'm not really doing u substitution, but I'm identifying what's my u and what's my a, just sort of for the purposes of this formula. But now I'm ready to just do this formula, I think. I mean, like I said, du is just dx, so nothing interesting happens. So I think I'm done. The answer is 1 over a, that's 1 over 2, arctangent of u over a. That's, arctangent of x over 2. Is that what that is?
Yeah.
Yeah, that's it. you never were too familiar with these three dudes, which maybe you weren't, because we didn't, I mean, we went over them, but we didn't. We had a lot of stuff we were learning. These are just three more things we were learning. But never knowing these too well might keep these a little distant in your mind. I mean, it's just these formulas. I got these patterns down. I know this goes back to this, this is this, this is, I see these patterns. You know, there's a big difference in this one and this one. They both have square roots, but this is the number minus the variable squared. This one is the variable squared minus the number. And that's different. You know, subtraction is different. You know, when I added these, I got the number plus the variable, but when you add things, you can add them in any order. So when I wrote it like this, it's the same thing, of course. Of course. But to distinguish between these two, well, this one's got this extra x out front, but you got to get this, the subtraction order is important. This is arcsine, this is arcsecant. This order is important. Let's try another. Look at this one. All right, so I just got mean all of a sudden. That's how I am. I go from basic to advanced. Sometimes I skip over medium. No, I'm kind of kidding. This is kind of medium. Advanced medium. Medium well. Anyway, look at him. Dude, who's he look like? And do you see a pattern? And by the way, the other thing you have to convince yourself of is nothing else you've learned this semester helps. I mean, that takes a while maybe, but to understand that you got no other formulas at your disposal. I mean, when I stare at this, the only thing he could be is this. Yeah. There is nothing else he could be. So I look at that and I sort of see an a squared minus a u squared. Is that what I see? A number. I'm calling that an a squared minus a u squared. I think it's arcsine. Don't you? You with me? Mm-hmm. All right. So let's fill in the details. What is the a? If that's a squared, what's a?
Squared.
All right. So does that scare you? That shouldn't scare you. It's just a number. Just as good as a 3 or 4. Cool. So there's my a. So what's my u?
2x.
So I have to identify that as u squared. If I got to think of that as my u squared. If I'm fitting the formula, I'm trying to form fit. I'm trying to fit formulas. If that's u squared, then what's u?
2x.
Good. Now that's important. Students screw that up all the time. If that's u squared, then u is 2x. Do you see it? Maybe you take the square root of both sides. Maybe you, right. All right, well, hey, if u is 2x, that's not trivial. That's going to generate a little 2 or a 1/2, or what's du?
2dx.
2dx, or move the 2 over, 1/2 du is dx.
Okay.
So I think I'm getting there. You know, I think this is an arcsine. And maybe I'm ready to just fill in all the details. There's my u, there's my a. But whenever you call something u, you have to do the little du step, because what you see is this problem is going to spit out a 1/2. And that's not part of the formula. It's spitting out a 1/2 from me from what I called u and the relationship with du, it spit out a 1/2 from that. How come this didn't spit out anything? Because u was just an x and du was just a dx. It was very boring and didn't spit out a 1/2. Right, this one's still kind of boring, but u is a 2x. So it spit out this 2, well not really, it spit out a 1/2. I mean, I'm ready to write down the answer. I feel like maybe I should play the replacement game, though. I mean, maybe not. The replacement game would be the 5 comes out. That leaves me a 1 on top. What about the dx? What about that dx? What about that dx? What about that dx? What about that dx?
Spits out the 1/2.
It's a 1/2. I'll pull that out there, du. So I just replaced the numerator. What's this denominator? The square root of 17. I mean, I could call it 17 minus u squared, I guess. Is that what right? Is that what I just did? I called that u. I mean, maybe I could call that a squared for a second, but anyway, now I see it. This is arctangent with a 5/2 out front. Not arctangent, I'm sorry. Arcsine with a 5/2 out front. Here comes the answer. 5/2 arcsine of u over a. What was my u? 2x over square root of 17 plus c.
Yeah.
That's a good one.
Yeah.
I mean, maybe it's a little medium-ish. Hey, I want you to see the subtle beauty of this stuff now. Watch this. See that problem over there? Okay. Look at this problem right here. So this is, see this problem? This was 5.8. This was an arcsine. It was very clearly an a squared minus u squared with a number on top. I mean, this was this formula. I took a little finagling to figure it out, but this was this formula, and the answer was arcsine. And this new guy I just wrote up here, who's very close to him, but different, is not. What's different about this one? Why is this different? It's got that x in the numerator.
Right.
Right, and these problems, look at these. None of these have a variable in the numerator. There's no u's or x's up here. I mean, this is a different problem. It's just that one little x made this a totally, I'm going to handle this totally differently. I can do it, though. Do you know how to do it? Well, I can pull a 5 out, but how am I going to do, what's the big strategy here? Yeah, u substitution. What's u going to be this time?
2x.
No,
No.
the entire denominator.
Oh, the entire.
But I actually misspoke. Not the entire denominator, but what's inside the radical. See, and you guys know that because you know how u substitution works. When you let u equal an x squared kind of thing, du is going to be you don't know this, do you? If you let u equal x squared, du is going to be an x, which is going to wipe that numerator out. This is perfect u substitution problem. What's du?
Okay.
Negative 8x dx. I'm happy.
Yeah.
I'm happy. I see this x dx. I see this is going to help me replace this. I like to move the 8 over. The negative 1/8 du is going to replace the x dx. Here we go. What about the 5? Pull it out front. What about the circled x dx? 1/8 du. 1/8, negative 1/8 du. What about the denominator? Square root of u. You guys with me? It's a cool little process. It's called u substitution. We've been doing it for a couple weeks. It's this cool little process. And it turns into this problem. And now you're supposed to know how to do this. How do you do this?
You just color it with the power.
It's a power rule.
Yeah.
You move it up and do a power rule. There's a negative 5/8 out front. You move this up, it's u to the negative 1/2. And how are you going to integrate u to the negative 1/2? You're going to add 1 to it. U to the 1/2 times, then you divide by 1/2. Some of you were screwing this up. You divide by a 1/2, but that means multiply by 2. Your quiz has issues. You had issues on your quiz with that. Cool, we're done. This had nothing to do with arctangent.
No, it didn't.
No, it had that x in the numerator, made it a completely different problem. Without the x in the numerator, I can't do that u substitution. Without the x in the numerator, it's this pattern. It's arcsine. It's subtle. There can be some subtle differences. I mean, with that x in the numerator, it's a different problem. Completely different problem.
Can I ask one question?
Yes. I'm going to finish this. Negative 5/4 square root of u plus c. But you can ask a question.
Okay, the question is this. If I had done 2x and then I get the 2, could you rename that x up there as, see, if it was u equals 2x, could you rename it as x equals u over 2?
Yeah. And then you're going to
This is much easier. I agree with.
then you're going to get yourself in a situation where you have a u squared and a u up top.
Okay.
So what are you going to do with a u and a u squared? It's kind of like you did with his x and x squared. You're going to have to do another u substitution. You're not really getting anywhere.
Okay. So.
I mean, you have to see this as a new strategy, as a different strategy than that one. Right.
So if we had that x up there, even though it looks like it might be an arc sign, but because of the x up there, it's not.
It's not arc sign.
So we need to do the whole denominator.
Right.
Okay. Except not the radical. Yeah.
Right.
Okay.
Look, right. The new formula today are these three new formulas, and look at them. You know, this is arc sign, and watch. If you had a u up here, it's not arc sign. Right. I mean, I just changed it. The numerator is a u. It's got to be a 1, and by the way, it doesn't have to be a 1. If it's an 8, what do you do with the 8? You pull it out front, then it's a 1, right? So.
Right.
But it can't be a variable up there, I guess. Here's another one. Watch this one.
Okay, that's where I was. Now that's where I was getting confused.
Sorry, this is a 9. Dude, look at this problem. Dude, look at this problem. Dude, look at this problem.
Yeah.
I could say that all day. I mean, there's so many good problems. Dude, look at this problem.
Yeah.
They're all cool and good. What are you thinking? What are you thinking? Any guy? Yeah. Anybody got any ideas?
I think I need this one.
Okay, look. So we're in this section 5.8. Maybe it's one of these three. But as you just saw, some old school stuff slips in every once in a while. This was not one of these three. This was something different. But anyway, maybe it's one of these three things. And if it is one of these three things, which one is it?
Arctangent.
Thank you. It's not these two because there's no radicals there, right? So maybe it's this. But if it's going to be this, then the numerator needs to be a 1. I mean, that e to the x up there is not good. But if you know, well, you can't pull functions out. You pull constants out. You don't pull variables out. E to the x doesn't come out because there's an x on it. And you don't pull variables out. You pull constants out. I'm still thinking about this. I'm thinking maybe I can fix the numerator. I mean, what would be the a? What would be the a?
3.
The 3. Yes, it would, because that's a squared. So a would be 3. What would be the u?
E to the x.
Good. If this is u squared, if that's what we're thinking, I mean, I'm trying my best here. Sometimes we trial and error, you know, but I'm not going to error, I don't think. Okay, so if that's u squared, then what's u?
E to the x.
E to the x. If u squared is e to the 2x,
Right.
then u is e to the x.
Right.
See, what if you squared both sides? You'd square this and square this. You know what happens when you square e to the x?
It's e to the 2x.
You get e to the 2x. Yeah.
You multiply x.
All right, so u is e to the x. All right, you guys are smart. What's du? E to the x dx. Are you happy?
It's up there, yeah.
Are you happy?
Yeah.
You're supposed to be happy. You're supposed to see what just happened. What just happened? If I rewrite this thing, that extra e to the x that was bothering me just got absorbed into the. It's the du. So that's du, and this is u squared plus 9. Does that look like this? It looks exactly like this, except things are moved. So I'm done. It's an arctangent. So what is it? Arctangent. Does arctangent have a 1 over a in front of it?
Yes.
Okay, the arc sine doesn't have a 1 over a. Hope I did that right.
Yeah, you
So,
did.
all right. So here I go. Arctangent has a 1 over a. That would be a 1/3. Arctangent of u over a. What's my u? What's my u? What's my
E to
u?
the x.
E to the x over 3. That's wild. That's the answer.
Okay,
That's
so
his integral.
that one. Okay, yeah,
Um,
that one.
hey, I got another comment. So on your quiz last week, it was a long time ago, but the very first question was, what was that thing? X cubed plus 5 log x? No.
No, it was 5 over minus.
Minus 5 over x.
Plus secant x, tangent x.
Tangent x plus e.
Alright, so I just wanted to help you with a couple thoughts here. This was on your quiz. This has nothing to do with U substitution. You know what this was, though? It was, again, the concept that you could integrate each term is important. So so really it's kind of like 4 little integrals in one.
Right.
I mean, you integrate each term. Now, some of you kind of know that, but you had some thoughts mixed up. Like, well, anyway. So it's 4 different integrals. So what's the integral of him? 1/4 x to the 4th. All right. What's the integral of him?
5 natural log absolute value of x.
That's right. That's just what he is. And, you know, technically, maybe you pull the 5 out in front. But listen, if you pull the 5 out in front, it's just in front of his own little integral. What I saw and what I'm worried about is a lot of people were pulling the 5 out here, but the 5 doesn't
Right.
come out here. It's not. There's no multiplied 5 on this guy.
Yeah.
See, you have to make it 4 separate little integrals, and then you can sort of pull the 5 out in front of him. But then there he is, right in front of him. He's not in front of everybody else. So some of you had like a 5/4. You had your constants. You had some issues with your constants. I mean, there's this concept of pulling out a multiplied constant. But you only pull it out right in front of what it's multiplied by. You don't. Anyway, and then this is just memorized, secant x. And then this is just easy. Right. But some of you did some funny things with these constants you shouldn't have done. Joining these together somehow. Because the 5's just in front of him. I was worried about that. I think I'll quit today, though. You can start working a little in 5/8. I'm going to take questions.